Hello students. Now I am going to speak about the monostable multivibrator using IC 555 in the chapter sequential logic circuits of digital electronics of third semester electronics and communications. Now first we will see the overview of this session. First we will have an introduction to monostable multivibrator, then we will see its circuit diagram and its working, then we will see the applications of monostable multivibrator, then we will see flip-flop as a bistable multivibrator, also bistable multivibrator using a flip-flop, then we will have some test questions and multiple choice questions. Okay, to start with, we will see the introduction for a monostable multivibrator. So here, as the name indicates, that it has a single stable state and a quasi-stable state, that is a temporary state. So the monostable multivibrator, as the name itself indicates, has mono means only one stable state that is there at the output continuously, and whenever you give a trigger pulse, the output changes for a short interval of time, and again it remains in the permanent state. That is, the stable state will be zero state, and whenever you give a trigger pulse, the output goes to high for a while, for a short interval, then again it goes to low. So the second point here is, it's also called as a one shot multivibrator, means that it has only one stable state. Then the third point is that monostable multivibrator requires a trigger input. So naturally, to change the state, you have to give a short trigger pulse as a trigger input. Then it stays in one stable state, that is the low state, as I said, and temporarily switches to high state only when the trigger input is applied. After a predetermined time interval, it comes back to its original stable state, that is low state. Okay, then you can see in the diagram, the monostable multivibrator has a input, trigger input, and output pulse for that input. Now the circuit diagram here, as you can see in the figure, it is having one external resistor R1 which is connected to VCC. Then this R1 is connected to capacitor C1, external capacitor, for charging towards VCC, and the other terminal of the resistor R1 and the capacitor together, these are connected to pin number 7 and 6 of the 555 IC. So pin number 7 is nothing but the discharge pin of the internal transistor, NPN transistor. Pin number 6 is the threshold input of the upper comparator. Okay, then you have one more resistor R2 connected to VCC, then this R2 other terminal is connected to pin number 2, that is a trigger input, and the continuous connection, as you can see, there is a switch, a toggle switch, negative trigger pulse switch, that is connected to the ground. Okay, so whenever you press the switch, the pin number 2 will get 0 volt. When the switch is open, pin number 2 is having VCC voltage, that is 1. So you will be giving for this pin number 2 trigger input 0 or a 1. Whenever switch is open, it is 1, and when you close the switch for a short interval of time, it is going to give a 0 input, that is for triggering the flip-flop, triggering the state, triggering input. Okay, so here you can see the waveform. The trigger pulse is a negative going pulse from high to low, and the capacitor charging voltage also you can see it is going to get charged from 1/3 VCC to 2/3 VCC, and the output pulse also you can see in the waveform. And here the points given regarding its details are: a short negative going pulse is used as a trigger input applied to pin number 2. Okay, that is a short negative pulse applied to pin number 2. Then The second point, what it says means pin number 7 and 6 are shorted and connected to VCC through R1. Here, as you can see, pin number 6 and 7 are shorted. They are connected to R1 through to VCC. Then capacitor C1 is connected to VCC through R1. Okay, the same point there, capacitor C1 is also connected. When trigger pulse is applied, output goes high. So normally the output will be low. Whenever you give a trigger pulse, what happens? The lower comparator will change the output to high, which is connected to set input. Therefore, the internal RS flip-flop set input goes high, so Q bar goes low, so the internal transistor is turned off. So therefore what happens, the capacitor starts charging, and since the output of the flip-flop is 0, so that is going to change the output to high. Because of a inverter, the output goes high for a short interval of time. And when the capacitor charges to 2/3 VCC, the upper comparator will change its state, and so the output goes to low. So when trigger pulse is applied, output goes to high for a short interval time. Output stays at high state as decided by R1 and C1 component values. Okay, so the capacitor discharging time and charging time both will decide the time period of the output high pulse. So when the output changes to high, what happens? The capacitor will start charging. Okay, what happens? The capacitor charges through R1, and how much time it takes to charge up to 2/3 VCC. Okay, so that is the time period of the high interval of the output pulse. So when the capacitor reaches to 2/3 VCC, what happens? The output goes again low. So you can see in the waveform, the charging period is the time period during which output is high. Okay, now we'll see the next slide. Here you can see the functional block diagram of the monostable multivibrator. The internal diagram showing all the internal components like the two comparators, RS flip-flop, and the internal 3 resistors also of 5 kilo ohm. All these are shown here, and also the external connections like R1 and capacitor C1. So here the points given are the capacitor. The first point we will see now. When a trigger pulse is applied to pin number 2, the internal comparator B detects this input as sets RS flip-flop. Okay, so as you can see, when the trigger input is given, the set input goes high, so its output is set to 1, so Q bar will be 0. So that is given to the transistor becomes off. And also this is going to it's going to make the output high through the inverter. Output goes high. When the capacitor becomes off, when the transistor becomes off, the capacitor C1 starts charging through R1. So we'll see the second point now. Here the second point is, this turns off the discharge transistor connected to pin number 7. Okay, that's what I said. The capacitor C1 allowed to charge through R1. So when the internal transistor Q1 becomes off, the capacitor starts charging through R1. When the charging voltage across the capacitor reaches the threshold voltage of 2/3 VCC, comparator A output goes high and resets the flip-flop to its original state. So when the capacitor charges to 2/3 VCC, upper comparator will change state, so the output of the RS flip-flop will change, so therefore the output goes to low. Here the next point is, this turns on the transistor and discharges the capacitor to ground through pin number 7. Then it expects another trigger pulse to start the timing process over again. So until you give the next trigger pulse, the output remains low only. No changes of any components states will take place until you give the next trigger pulse. Okay, we will see the applications. Here, as you can see, the first application is the monostable multivibrator is used as delay and timing circuits. Okay, it is used as a time delay circuit. Then it is also used for temporary memories, for temporary storage of data. It's used as a temporary memories. It's often used to trigger another pulse generator, since it generates a mono pulse at the output, so it can be used as a trigger for another pulse generator. It's used as a frequency divider, so the given frequency can be divided, so it's used as a frequency divider. It's also used as a sweep generator for CRTs. Cathode ray tube sweep generators may be made up of this monostable multivibrator. It's used as pulse stretcher. A pulse stretching can be done by using the monostable multivibrator. It can also be used in the pulse width modulation PWM circuits. Okay, so that is about the monostable multivibrator. Now we'll see flip-flop as bistable multivibrator. Okay, the first point, just we'll see it. It has two stable states, that is a low and a high output states are perfectly stable. So whenever the output of a circuit has two stable states, that is called as a bistable. So it is a bistable multivibrator. So the flip-flop which has two very stable states may be used as a bistable multivibrator. So let's see the second point. It says it stays in one stable state until a new trigger pulse is applied. So for changing any state, you have to give the trigger pulse. That is, it is having two stable states, high and low. So to change from high to low, you have to give a trigger pulse, and similarly from changing from low to high, you have to give another trigger pulse. Therefore, it requires two external trigger pulses. Okay, so flip-flop, a sequential circuit, is an example for bistable multivibrator. So here, okay, here you can see the diagram also at the bottom of this slide, the bistable block diagram. So it has two inputs, two trigger inputs, T1 and T2, and output has two stable states, high and low. Okay, we'll see now some more details about bistable using a flip-flop, bistable multivibrator using flip-flop. So we can use a D flip-flop. As you can see here, a D flip-flop can be used as a bistable multivibrator. Here in the diagram you can see the D flip-flop is there, which is having output Q and Q bar. This Q bar is connected back to D input, and the clock input of the D flip-flop is the trigger input for the bistable multivibrator. So here this Q bar output is of the D flip-flop is connected to its D input. The output of D flip-flop will change either from 0 to 1 or from 1 to 0 at every trigger pulse. In the absence of trigger, the output will be stable in both states. Okay, so that means this bistable multivibrator flip-flop has two stable states. When you give one pulse, say the output changes from low to high, so it remains high for a long time until you give the next input. Until that, the output remains high only. So when you give a next trigger pulse, what happens? The D flip-flop, it will change the output from high to low, and it remains low again for a long time until you give the next trigger pulse. In this way, to change the output from low to high or from high to low, you have to give one trigger pulse. So in the truth table also you can see the trigger input whenever you give a trigger input, the output will change. So here when the trigger input, first case is D is not connected, that time there is no change. When you give D equal to 0, output will be 0. When you give D equal to 1, output will be 1. So that is going to change due to the clock pulses, the trigger input. Okay, so here for this session, whatever references were taken are shown in the slide, and here are the names of the team members. So with this, I will conclude this session on the monostable multivibrator and bistable multivibrator using a flip-flop. Thank you.